video is brought to you by Vita Bee Health. Thanks Vita for sponsoring this channel. Please check them out, link in the description of this video. Hello everyone! Before I introduce today's guest, let's take care of some housekeeping first. My recent video about GeoCure caused a lot of discussions as expected. And I want to say that I had the pleasure to meet over Zoom with the management team of GeoCure to listen to them. The conversation was very interesting, and I am working on a new video to address all the questions that are coming my way because of that video. So stay tuned, and if you haven't already, sign up to my email list so you can be notified when I release the new video. Thank you. In today's episode, I had the pleasure of speaking with Dr. Scott McArt, an expert in pollinator health from Cornell University. Dr. McArt has been at the forefront of research on pesticide damage to pollinators, including honeybees. He has been on this channel before, if you remember, a while ago, when we discussed his famous pesticide report, a document that opened my eyes to the problem that I like to frequently revisit here in this channel. You can find the report and my first conversation with Scott in the description of this video. In this interview, we took the time to discuss the recent invasion of Varroa mites in Australia, how misinformation about pesticides is affecting beekeepers and pollinator health, and his upcoming new book he's writing during his sabbatical in Australia. We explored the complexities surrounding pesticide use and how important it is to cut through the noise of misinformation to protect our bees. If you've ever been concerned about how pesticides are impacting your colonies, you won't want to miss this conversation with Dr. McArt. And now, I present to you Dr. Scott McArt. All right, Scott, welcome back to the show. It's been a long time. How are you, my friend?
I'm good. How are you? Thanks for having me again.
It's good. It's good to have you back. So I heard that you are in Australia. Can you tell us a little bit about what you're doing over there?
I am doing one of the greatest things that you can do in this job as an academic. I am on sabbatical, which is, I don't know how this came about, but somehow in academia, sabbatics became a thing, early over 100 years ago, I'm told. So I'm over here in Australia, visiting the country, interacting with some folks here on the Varroa situation, which has been pretty interesting to monitor over the past year. I'm sure almost all of your viewers know that Varroa recently invaded the last continent on Earth other than Antarctica where it wasn't present, and that's Australia. So it's been, yeah, interesting to interact with folks on that topic. And then mostly what I'm doing is, well, still trying to run my lab back in Ithaca. Unfortunately, even on sabbatic, you can't just, go away from all of those responsibilities. But then the other thing that I'm doing is I'm writing a book on pesticides and bees.
Oh, that's an interesting topic. And actually, perhaps the reason I invited you today, because I am following your work, and I have to say that I am impressed with everything I see and the quality of your writing. So I want to do some kind of propaganda here. I want to promote something from your lab that I think is everybody should know this. Just give me 1 second. Let me put this on the screen here.
Sounds good.
So we are here, notes from the lab. So tell me about the notes from the lab, because I'm following your monthly publications. This is a publication that you published on American Bee Journal. Am I correct?
Yeah, so I was approached by, let's see, how many editors ago was it? I think maybe it was only 2 editors ago at American Bee Journal back in, oh God, how many years have I been doing this now? I think I've been doing it for 6 years. I don't know. You can scroll to the bottom there and see when my first article was at ABJ. But I was approached by Kirsten Trainer when she was editor of American Bee Journal, because she wanted to increase the amount of scientific peer-reviewed content that was in the Bee Journal. I had just been hired by Cornell, and I have an extension appointment, which means that I have the great privilege of interacting directly with beekeepers and other folks, other stakeholders. So going out and actually bringing academia to the public, and hopefully getting a lot of information from the public to improve academia as well. So it was really the perfect fit. And what I did was that I would start writing a monthly column called Notes from the Lab, where I try to summarize the peer-reviewed literature, be relevant to beekeepers, and try to summarize it in a way that just gets rid of all the scientific jargon, gets rid of all of the stuff that only scientists or specialists in a particular field might understand, and make the articles accessible to anyone from the public. So if I've been doing my job well, I don't know, you guys tell me if I've been doing my job well. I've been doing this for, I think, 76 monthly articles now, so for several years, and it's yeah, it's been a lot of fun. I enjoy getting the science out.
No, it is a language that everybody can read, is a must read to anyone from any field that wants to be informed about the science behind pesticide use and many other things that you are covering there. So I want to promote that. And by reading that, following your work, I got caught with three particular articles. This one from January 2024, the one from February 2024, and the one from March 2024 that I want to go over with you and get your thoughts on that, because you do toxicology in your laboratory. You research how pesticides affect pollinators, and there is a lot of good work coming from there. And I know there are many other folks also doing that kind of work, but apparently I only see a handful of people that talk about like publicly, and I'm not sure why. So I want to get that. I'm gonna ask you that because you are very spot on those articles. Let me put the first one here, if I have your permission, just to put the title here. So, how to make pesticides safer for bees. This is from the January of 2024. Can you give me I want to, if you want to go and read this, please go to the website. The website is here, blogs.cornell.edu, McArt Lab, Notes from the Lab. I'm sure you can find this on the internet. And then you click here, Notes from the Lab, and you have access to the PDF of each of this completely for free. Thanks Cornell University and Scott for release this content for free for everybody.
And thanks to ABJ as well. There was
yes.
there's been quite a bit of discussion over the past several years whether they're okay with me posting these onto my own website and just making them available for free. But what we decided is, or what Eugene decided as editor, so Eugene Makovich is the editor of ABJ right now. He decided that he really likes this column and he wants this information to get out more broadly than just subscribers to ABJ. So he's been okay with us just posting it for free on the internet.
Oh,
so thanks to ABJ.
That's great to know. Thanks, ABJ. So this is a fantastic view about the future, because we need, that's what I'm doing here. I felt the need to push this information out based on my personal experience as a researcher and as a consultant for the beekeeping industry. I see many things that really fit what I see in real world on your writings here. So it is a must read. And I want to ask you how to make pesticides safer for bees. I don't think we have a problem to say that we have the data. I don't think that's a question anymore. Do you think this is a question anymore? I think we have thousands, if not a lot of data. And now the question is how we implement and make sure that everybody knows to push decision-making people to do something using data-oriented policies, I would say. So how we make pesticides safer for bees?
Yeah, so I might even back up just a little bit beyond that and just say, all right, so you introduced this as saying there were 3 articles that caught your. And I'm glad they caught your attention. So that was the purpose of writing them. Thank you for realizing that trio was published. I also just wanted to give a little bit of background of why I wrote these three articles in sequence. So two of those publications came out at about the same time. Just to clarify, the first two articles are just summaries of other people's work. So this first article is a summary of someone's, who is it? Adrian Fisher is the lead author of this particular article. There, right here, perfect. So he had a nice paper in Bioscience, which is a pretty prestigious journal, about how to potentially reform the pesticide regulation to protect pollinators, as you can see here. In the process of writing this book that I am writing right now on pesticides and bees, this is one of the chapters. Actually, it's maybe turning into two chapters about how, basically trying to pull back the veil of what exactly does occur at the EPA and other regulatory agencies around the world. How are pesticides approved? What decisions go into, whether or not they're deemed to have risk to bees or other organisms during the pesticide registration process? Is it adequate? Is that process adequate? And then what happens after a pesticide actually goes out there in the real world? Is any follow-up done to see if all these predictions from the risk assessment process are actually borne out there in the real world or not? So I was writing about this in the book. This particular paper was published, and I thought, oh, this is fantastic. The second article in the sequence was a paper that was published at about the same time in a very high-profile journal. So that's in Nature, and this is a paper that actually makes the links between the inadequate pesticide registration process in Europe. So I guess I'm giving away part of the story there, that yes, we do have evidence that the pesticide registration process is inadequate, this paper being one of the key ones that was just published. And showing that, this inadequate pesticide registration process results in harm to the ability of bumblebees to reproduce across, I think it was 108 sites in Europe that were used. So you can see that big negative correlation in all of those figures right there. That's showing that when there's more pesticides at these sites, bumblebees don't reproduce very well. Now, obviously, if the bumblebees don't reproduce very well, that means their population dynamics might be impacted. Why is that important? Well, we're worried about pollinator declines. What are pollinator declines? It's declines in populations of those pollinators. So here's evidence right now of a link between pesticides and pollinator declines, shown very elegantly in this paper. So that's another. That's actually several chapters in the book, is the evidence for whether there really is a link between pesticides and pollinators or pollinator declines. And I can share with you that yes, we're beyond the point of speculating about this. We know this is true now, and now we can also link it in part to the inadequate pesticide registration process in several countries, not just Europe. So that was the reason for those two first articles that came out at the time that I've been writing about this topic myself and wanting to get a little bit more information out there. I thought about waiting until I actually published this book, but it's going to be a while before this book is published, and these were just very timely articles. So I decided, oh, this is great. I'll just get these summarized for ABJ. And then the third article is actually not about any particular paper. So I went a little bit off script from what I usually do for ABJ. And instead, I decided to write about the third major topic that's in the book that I'm writing. And that's about this science policy interface that's occurring right now and all the different players that are involved in that. There's certainly scientists that are contributing information to policymakers in a good way. There are also scientists, a handful of scientists that are contributing information to policymakers in a not very good way. So we waded into that topic a little bit. And there's also quite a bit of disinformation that occurs from the pesticide industry and other folks that are affiliated with the pesticide industry in trying to influence policy. And there are multiple reasons, both financial and sort of motivational, depending on political views of various people. There are multiple reasons that are entangled in those different reasons for why people are doing this. So I decided to weigh into that a little bit in this article. It's not very extensive. I give a couple concrete examples, all with receipts. Everything that I do is referenced with receipts. So all of that information is here in this particular article. I get much more into this topic in the book that will be, it's still not finished yet, but it'll be getting finished over the next maybe half a year or so.
I'm looking forward to see that book because I'm trying to collect myself, to get the information out there. I'm reading a lot. It's not my field of expertise, so I'm always a little, when you're not working in the field, you know science, that you can get some, get caught in some sort of experimentation that you don't know too much about it, and maybe it's not the best way to do the job and things like that. But after reading the report that you guys put together with all the evidence, there was a slap in my face. This is just too clear. That is a slap in the face. There is nothing you can do. But I thought that was gonna be like a boom, like everybody's gonna understand and go up. But no, there is this. I feel there is a suppression process in this, that do not allow that to move forward. I don't know if you agree with me, but I feel there is some forces acting on that. And then I read your third, this one that is in front of me, and you have some very interesting experience with some scientists that I'm not sure if they are misinformed or doing something with an agenda on purpose. I don't want to put, pointing fingers, because I was mistaken in the past myself, and I was sure about things that after a while, like, I realized I wasn't. Maybe that could be the cases for some of those folks. But you encountered some interesting counter scientists trying to counter all the arguments that you and your team put together. But they couldn't convince me at all. And that's why I want to have this conversation with you here today, and maybe asking you again. Maybe you should go back here in the first one so we can get this timeline.
Sure. Mm-hmm.
How in a very brief overview, how the EPA is performing their work regarding pesticides, and how that is problematic, and if there is anything that we can do. I know this is probably your whole book, but for the people at home that doesn't know much about it and want to have a little glimpse about your book, how that works, how the EPA works on that, and why it's problematic.
Sure. Yeah, sure. And again, I think you've hit the nail on the head, right? So this is why I am writing this book right now. There's a lot of misunderstandings both in the research community and within the public, including policymakers, about how does this actually work, right? So how do we know that pesticides are safe, not just for pollinators, but non-target organisms in general, and humans in general? There's quite a bit of misunderstanding in both in the scientific realm and in the public sphere. I'm hopeful that this book will at least partially address, some of those misunderstandings. This is not the first book to ever be written on sort of regulation of pesticides and inadequacies at both the EPA and other government agencies. It is the first book to be written with part of the focus on that topic related specifically to pollinators. And then some of the other aspects of the book have never been covered in books before. But the goal with everything that I'm doing on this topic right now is to make it as useful as possible to people who actually want to use information. So my hope is that this will be read not just by scientists who are trying to understand this, but also by the public and by policymakers who are considering new things to do, yet either at the state or the federal level. Okay, so all right, the question is how to make pesticides safer for bees. That's a pretty big question.
Yeah, sorry about
And
it, but
yeah, no. Well, hey, I just put it in the title of this and said, hey, yeah, we can answer it in
yeah.
3 pages, but yeah, I don't think we can.
Your fault.
That's right. Yeah. I would say, just to start out with, risk assessment is a tricky business, right? So it's very hard to conduct very thorough risk assessments. Also, because the federal government is in charge of this, the EPA being the current entity that is taking this on, it becomes politicized. There are multiple books that have actually waded into the topic of the politicization of EPA. Different agencies, or sorry, different administrations that come in either de-emphasize what the EPA is capable of, or they start to bolster what the EPA is actually capable of. Our current administration is relatively friendly to the EPA, so they're not slashing budgets and literally, previous administrations have actually disbanded the entire library of information that has historically been gathered at the EPA, which is amazing. It's not even possible, right? But because it's political, that's why it's possible. Ultimately, if we really wanted to do this, what we should do is we should make the EPA separate from politics. It should be something like the Federal Reserve. It should be, something that is not dealing with the whims of different politicians that are coming in for 4-year terms. It should be something separate that really, runs in parallel to the government, potentially with longer terms, 10-year terms, for example, for the administrator of the EPA. That's probably wishful thinking, that would actually occur. So, all right, what should we do within the current context? There is currently a pretty interesting development that is occurring within the EPA that I touch on in the book, but not in this article. And that is the shift in focus, or at least supplementation of focus, on endangered species. So now a lot of the risk assessment that is being developed and will eventually be implemented is to ensure that endangered species don't go extinct because of pesticides. That really does change. There's the models that are getting introduced right now. They're provisional models that will be renewed, or sorry, not renewed, revised over the next several, at least months, if not years. Those models are really fundamentally different from the current models that are involved in risk assessment. But the original risk assessment models are not going away. So risk assessment models and approaches are still there for how they have been functioning for the past at least a decade now for pollinators. All right, now, so with that length about sort of maybe a big picture way, pie in the sky, to think about how we could change the EPA, and then also some of the current workings of the EPA that are underfoot to try and improve risk assessment from this endangered species perspective. Now let's focus even more narrowly on what does the EPA currently do. So the current risk assessment process is a 3-tier process. So tier 1, tier 2, tier 3. And it largely, well, it almost exclusively focuses on single active ingredients. Okay, so if a pesticide is trying to be registered, a company brings it forward, and the first tier is largely concerned of how lethal is this particular pesticide in short-term bioassays to non-target organisms. Okay, so the primary focus here is an LD50 for adult honeybees. Honeybees are the main model species for all pollinators. Even though we have 20,000 species in the world, honeybees are the only model species that are used right now. That's probably not a bad choice for at least these LD50 studies, because honeybees are about the middle of the road in terms of body weight. And we know that body weight is a very predictor of lethality or toxicity to bees. So having a middle of the road organism is probably not all that bad for these toxicity assays. Honeybees also happen to be very different from all others in how social they are. And there are multiple social detoxification mechanisms that they employ, which are fundamentally different from the other 19,999 other species of pollinators in the world. So they're actually very bad as a organism in that respect. That's relevant in tiers 2 and tier 3, unfortunately. But we'll get there in a bit. Okay, so largely this tier 1, what happens is there's LD50 studies that are conducted. Not required, but encouraged right now are larval bioassays for honeybees. And in those larval assays, there are some sublethal effects that are monitored, but they are not required to be monitored. And it's pretty anecdotal how that data is actually taken. So there's nothing really structured in terms of requirements for sublethal assays. One of the things that is a very quick, initial thing that can be improved in this pesticide risk assessment process is to formally commit to having sublethal assays included into the pesticide registration process. Why is that important? Well, pollinator declines are a product of two things. Pollinator declines are a product of one thing. It's population change, right? Population change is a product of two things. It's how much organisms die, right? How many organisms die, and then also how many organisms are born. That's what governs population dynamics. Just like your family, right? You have your grandparents. If I unfortunately pass away, your family starts to shrink. If you have more children, your family starts to grow. That's the size of your family, but it's also exactly analogous to how a population might change. For example, a population of pollinators. We currently don't include any risk assessment for that to have effects on reproduction. Given the fact that that's half of the equation of population change, and the main thing that we're worried about is population change of those pollinators, because that's what we're concerned about, pollinator declines. That means we're missing half of the equation in risk assessment. Okay, so there's number one. Yeah, I don't know. I'll stop there. What do you think, Roberto? Do you have any questions so far?
I am following. So it is a very important thing, and we see example of currently problems that's happening in the world, I would say, with population shrinking, like in Italy and Japan. There are, the human population are shrinking, and it is becoming a problem. They even need to endorse immigration, because if you continue that pace, a whole country might be in big trouble. And when we're talking about pollination and pollinators, I don't even think we are able to access the whole importance of these several thousands of species, what they do to keep life the way we know here in this planet. So when we see the decline of those populations, we don't even understand the kind of trouble we're going to be in the near future. That's my assessment here. So that's what makes me afraid of what I see, and even make me even more afraid is to see how people react to that information that the pollination is going down, pollinators are going down, and some people just, well, who cares? That's what happened. This is life. This is nature. Some organisms die, some organisms live. That's natural selection. And I don't even know how to respond to this. Sometimes I feel like how that equation works, because life is connected. We are all connected, and we need that diversity to get the balance that we need. Otherwise, it's mass extinction that comes with those things. It's big problems. So we need to use reason and science to trying to avoid problems. That's the way I feel. And when I see that we have the data and we have a regulatory path that is being easy to demonstrate that I have some problems, I want to know more about it and how to educate people and policymakers. And that's why I got to your work, and I'm trying to do this kind of podcast now.
Perfect. Yeah, no, I think, I mean, again, zooming out to the bigger issue, we're already very narrow. We're focused on tier 1 of risk assessment at the EPA for pesticides and pollinators. But yeah, if we zoom back out to the bigger issue, there are two main environmental issues that are serious issues right now. One is climate change, and the other is the biodiversity crisis. Climate change, it's very clear that we humans are having an impact on climate in this planet. That is, it's true, right? There's millions of scientific studies that have been published now, if not hundreds of thousands of scientific studies that have been showing that this is true, that there is a link between our activities and the warming of the climate. Some people might argue that, okay, well, sure, we're having an impact on the climate. It's really not all that bad. We have many studies showing the link between changes in climate and things that are not good for human persistence in certain locations on this planet. So we are going to be seeing over the next, probably just a couple decades, that people are going to need to move from coastal areas because the ocean is going to be, coming up, et cetera. But anyways, we don't need to talk about climate change and displacement of people, but this is a big issue. And then from the biodiversity perspective, so that second major crisis that is occurring due to human activities, yes, pollination and pollinator declines are one of the things that is occurring with the biodiversity crisis that is occurring across the planet. It is truly a crisis in some respects. So for some, loss of biodiversity, yeah, it's a bummer to lose species, right? Like, I would hate to lose species that was being lost. But in terms of their value to humans, the argument could be made that the value of some species might not be super high. So for example, there's currently quite a few extinctions that are occurring here in Australia. Marsupials, especially nocturnal marsupials, are one of the main groups of organisms that's having major problems, and there are several species going extinct. The argument could be made that small nocturnal marsupials, it's a bummer to lose those species, but in the end, it's really not, they don't really have that much of a benefit to humans that we know of right now. For pollinators, it's a little bit of a different story. If we lose pollinators in sufficient diversity we start to lose the main group of organisms that pollinates the food that we eat. So if we have a shortage of pollinators in the future, if we really don't do anything about this topic, it is very conceivable that we will just simply not have the animals in sufficient abundance and diversity to pollinate the fruits and vegetables that we eat and the seeds that are necessary to grow various things that we eat. We're not in that situation, thankfully. We're not in that situation right now. There is evidence that there's shortages of pollinators, that if there were more pollinators in a lot of US crops and world crops, that there would be improved yield, which has economic benefits for farmers, but also just nutritional benefits for us. But we're not in a situation currently where the shortfall is to such a high degree that we have to worry about feeding people on the planet. That could change the course of whatever we're doing, to pollinators doesn't change, because the writing is definitely on the wall. We are having an impact on pollinators right now. There are declines occurring in both the diversity and abundance, and we know several of the factors that are contributing to that one of them being pesticides.
And regarding pesticides, what are we doing about that? So that's the question. We have this situation on EPA. So they have a job to do. It is a tough job, as you mentioned. And at the screen right now, apparently we have how it's done right now in A, and in B, how it's done in Europe or something like that, or a proposal how to change things in the...
Yeah, sure. So we've been looking at this figure for a little while, but no one has explained it. So here, why don't I explain it? So, so this again, this is not my figure. This is
Yes.
a figure from the paper that I summarized.
And before you start, I just want to mention that I will cover this whole paper with the author in the near future with much more details. We just need a little overview because I think it's a great paper with a lot of good information. So I'm going to spend a lot of time making a lot of content about this publication.
Perfect. So, all right, what you can see on the left, that's the sort of circle of what occurs during the registration process currently. And what you can see here is you get a new pesticide right at the top. It undergoes what I've already described, the sort of tier 1 test, these toxicity tests under laboratory conditions. And you can see there's only one species there. So that's just Apis mellifera, our one organism that is used for all pollinators. What's going there is contact and oral exposure. So when these LD50 studies are done, they're done in 2 ways on adults. One is by contacting the organism. They just dose the back of the thorax of the organism, and they determine the dose, which results in 50% death of all of the different individuals that they test. The other is oral, so that is feeding particular doses to the bees, and again, the goal is to figure in which 50% of those organisms die. That's LD50. Okay. What's not included there is the larval assays. The reason for that is they are still not required by the EPA. They are strongly recommended, and what I'm told from people who have actually gone through my lab and now work for industry, so hopefully bringing pollinator-friendly practices to industry. We're infiltrating industry with folks from my lab. Anyways, what I'm told from folks is that pretty much every pesticide at most companies nowadays does submit data with these larval assays. So it's not just adults that are being tested, but it's also larvae that are being tested. And those larval assays do include some sublethal responses. So it's not just LD50, but also they look to see, all right, how many of the larvae actually survived into adulthood and, survived into pupation and did actually pupate. Many actually went through the pupation process and actually turned into adults. How long did it take for these larvae to actually survive? Not just, what was the dose at which 50% of them died, but how long did they survive at the sublethal doses? Again, none of that is required by the EPA, but some of that data is being submitted by the pesticide registrants.
Okay. I'm following.
Okay. So, let's go then. Let's scroll over to the right side and see what the proposal is over here. Okay, so again, this tier 1 estimate, you can see that the chronic tests under laboratory conditions are now proposed. This a formal part of the tier 1 process, so not just have this informal, actually some sublethal responses, but actually a real sublethal response. These chronic tests and measuring sublethal impacts, making that a formal process. And then you can also see that, hey, there's 2 types of bees there. So another thing that should probably be done if we really care about all pollinators, all 20,000 species of pollinators and not just honeybees, is we should include other pollinators in this risk assessment process. What you can see there is a really big bumblebee and a medium-sized honeybee. It's probably also a good idea to have some small bees, or maybe some other types of pollinators like flies or butterflies, etc., in that process.
What
Obviously,
good candidates in your opinion should be included? There is some good model candidates.
Sure. Yep. So there's basically 4 lab rats for bees that are available in the world. 2 of them are shown here. So honeybees, there's a good reason why they're used as a model organism in the lab, and you can do these tests on them. Bumblebees are another one that does very well in the lab. There's a couple different species that are very abundant in the world. In the United States, it's the common eastern bumblebee, Bombus impatiens, which is produced by 2 companies commercially. And then in Europe, it's Bombus terrestris, the buff-tailed bumblebee. Those are used for, actually, that is a problem in of itself. Sometimes they're shipped to other areas of the world and they get out and they invade those places and cause all problems. But without getting into that topic, what we can say is that they're available in at least Europe and the United States, and they could be used formally in the pesticide risk assessment process. And then there are 2, so those are 2 social bees, honeybees being highly eusocial, and then bumblebees being primitively social. So there, again, I sort of touched on this earlier, and we can get into this in the later tiered assessments. But sociality, it turns out, really does matter in terms of their susceptibility to various stresses. Generally, the more social you are, the more strategies you have for pesticides, and the more resilient you are to pesticide exposure. So honeybees being one of the most, well, perhaps the most resilient species on Earth to pesticides. The subsocial species like bumblebees being a little less resilient. And then the third category of bees is solitary bees. Solitary bees aren't here, but there actually are 2 species that can be considered lab rats. One is mason bees, so bees in the genus Osmia. There are 2 species in the United States that are cultured and actually sold commercially. So both of those could be used. Osmia cornifrons, what is the horn-faced mason bee? Sorry, blanking on that there. And then Osmia lignaria, the blue orchard bee, which is very beautiful and is used for pollination out west. And then there's also one mason bee that is cultivated and used commercially in Europe as well. And now I'm totally blanking on this is bad of me, but I'm totally blanking on the name of that bee. It's another bee in the genus Osmia. And then finally, a second of solitary bees is the leafcutter bees. So the primary one being Megachile rotundata, or the alfalfa leafcutter bee, which is again cultivated commercially, especially for alfalfa pollination. Those bees are both smaller, so bumblebees being the biggest, honeybees being the second biggest, mason bees being a little bit smaller than honeybees, and then alfalfa leafcutter bees, I think about half the size, half to a third of the size of honeybees. So that would provide a nice suite of sizes of the bees, which would be relevant for tier 1 testing. It would also provide a nice suite of sociality. So going from solitary bees to primitively social to eusocial, which would be very advantageous for tier 2 and tier 3 risk assessments.
Got it. So that's much more complete and cover much more ground of the potential differences in bees. Okay, what's next?
Sure. All right, so there's tier 1. So let's go back over to the original model here, and I'll try to go a little quicker on this so we don't get too bogged down with this entire this paper. We can focus on some other stuff for the rest of the discussion.
Yeah.
But basically, all right, so we've got a little bogged down in tier 1. Hopefully we haven't bored everyone who's listening to this podcast. If you are bored here, perk back up. We're going to go a little bit faster now. So the rest of what's shown here is tier 2 and tier 3. So tier 2 is what's shown in those field cages. So now gone, yes, estimating exposure from a model. That's part of tier 1, but then so there is a little bit of modeling that occurs in tier 1, but it's all just it's complete guesses about what exposure might actually be. Then what goes on is they put bees in field cages and they spray the active ingredient on the plants in the field cages, and they see what do bees bring back in terms of pesticides, how many bees die in these cages, and how does the colony do. The main the colony. This is it's really important to start considering other bee species, because we know that those honeybee colonies are very resilient to pesticides. I'm sure there's beekeepers listening to this podcast saying, "Hey, my bees aren't resilient to pesticides." And you're right. There's certain problems with pesticides and bees, but across all bee species and different groups of sociality in bees, honeybees are the more resilient of them. So getting some solitary bees and subsocial bees in these tests would be really good. The other thing that is a little problematic in this particular tier, and this will fit into tier 3 as well, is they're spraying one active ingredient. Okay, the focus throughout this entire registration process is on one active ingredient. That is simply not how pesticide exposure occurs in the real world. To put some real numbers on that, some work from our own lab has shown that honeybees are simultaneously exposed to 17 pesticides on average during commercial apple pollination. Honeybees are exposed to 35 pesticides on average during commercial blueberry pollination. And we also know that it's not just the focal crop that's where they're picking up those pesticides. In fact, it's probably less than 50% of the time what the honeybees are actually picking up is pesticides from the focal crop. They're actually picking it up from a lot of places outside of the focal crop that may or may not be adhering to pesticide label language saying certain things about how to minimize risk during bloom, because they might be spraying those pesticides outside of bloom, even though the bees are going and foraging on wildflowers that are receiving from those sprays. So, this is a very complex cocktail of pesticides that bees are exposed to in the real world. And yet what is being tested here is single active ingredients in very controlled environments for tier 2. And then in tier 3, which is at the bottom here, showing field tests with no cages, the focus is only on active ingredients. So they only focus on the active ingredient being tested. Believe it or not, all of the other pesticides that may be coming in as co-exposures are considered noise in those particular experiments.
Whoa. Wait,
noise is one way to consider that, or it could be considered as what's actually going on in the real world.
That's a good. You're a gentleman. I'm not that. I'm not a gentleman, I would say. I'm gonna have to interrupt you. So let me see if I get this straight. It's something that I made some videos in the past when I was started to put my head on this, because again, I'm not from the field. I need to read and take conclusions by myself as a scientist, trying to see what's right and wrong. Something that got my attention in the past was what it's called synergistic effect. This terrified me in many different levels, including my own health, because based on what I'm seeing here, there is no way. We're talking about combinations of 32 different pesticides in different concentrations that can go everywhere, and these are not tested. So we know that combination of two little things can become a bigger thing, and could explain one of these big losses that we have somewhere, and then somebody that, oh, we messed up, let's stop doing that because the shit hit the fan, let's put this way. And then we don't know exactly what happened in real life with those chemicals. What's the combination of 32 compounds in different quantities? This is almost millions of potential scenarios, and there is no way to test it, right? Then nobody's testing, because this is isolated, the chemical. So we do not include over there the how do you call adjuvants, whatever that is.
Yep.
I'm working on some videos about that too. I was surprised by the things that I read. So this is a big
Yep.
flaw in this system. You know, there is the only real experiment happened in the field and with us, basically. That's a problem.
Yeah. Okay. So this is a big topic, but here, let me start wading into it. So yes, pesticide interactions are absolutely something that to be concerned about. So we have multiple studies showing that synergisms occur, antagonisms can also occur. So
Yep.
it can be that what is analogous to a drug-drug interaction. It could be synergistic or it could be antagonistic. I would say some of the more important work that has come out on the topic is in California almond pollination, and is coming from Reed Johnson's lab at Ohio State University, where he has conclusively shown that some of the fungicides that are used during California almond pollination are highly synergistic with some of the pesticides that are still in the pollen and nectar. They're just residues that have remain in the pollen and nectar, even from pre-bloom sprays in California almond pollination. That is almost certainly contributing to major stresses on the bees in California almond pollination, is those fungicide insecticide synergisms. Reed has worked very well with the California Almond Board and California growers of almonds in California to at least get growers to reduce the amount of insecticides that they're spraying during bloom, because there are growth regulators that are approved for use during bloom for God knows reason, probably something related to the inadequacy of what you have in front of you right here. But they clearly have major problems for honeybee larvae. Reed has shown that and contributed those data. So he's at least gotten growers to stop using insecticides or greatly reduce their insecticide usage during bloom in California almond. He has also gotten some growers to reduce the amount of fungicides that they apply during bloom that we know do have an interaction with those particular insecticides that are still residues in flowers, during bloom. So some fungicides will have synergisms with insecticides, some will not, and there's various degrees of synergism that might occur. I think this is one of those victories, I would say, for pollinator health, and a victory for science informing this sort of tense environment between growers who are trying to protect their crop, not have a major pest or pathogen problem, but also not wanting to harm bees. I don't know a single grower who wants to harm bees, right? So they're in a tough situation, right? They have to protect their crop.
That's correct.
Yeah, they have to protect their crop, and they're going off of the best information that they can possibly have. Every interaction that I have with growers that we work with, and we work with a lot of them, every interaction, save for a couple, has been extremely positive in terms of me bringing data to them and potentially recommendations within their own operations. So anyways, not to get too off track, but to focus on Reed's work and the California Almond Board and growers in California and beekeepers, I think there are some major successes that have been had on this topic of synergisms. But that's one crop. Really the easiest crop to do that in, because there's such a tight association between the need of almond growers to have honeybees come in. If they don't, there's no crop, right?
Yep.
Whereas all other crops throughout the world are not that reliant on honeybees. Sure, honeybees contribute to pollination, but there is always an influence of just the wild pollinators from nature that are coming in and pollinating their crops as well. So there, the tight link between the grower and the beekeeper is not quite there. For blueberry, for apple, for pears, for citrus, for whatever else that growers might be wanting pollination. Because it's not quite there, there's not quite the investment in ensuring that the beekeepers aren't going to be complaining about losses during pollination. So this topic of synergisms, yeah, from a real world perspective, it's still needed. Much more work is needed. Okay, so there's a start to talking about this. A second thing that I would highlight is it's not impossible. Okay, drug-drug interactions are tested for during the approval of drugs, right? The pharmaceutical industry does, and the FDA, when they approve different pharmaceuticals, they require these tests for drug-drug interactions. This is why when you go and look at whatever pill you're taking, you can look on the back and you can say, all right, are there any medications that I should avoid when I'm taking this particular drug? Is it alcohol that I should avoid? Should I avoid taking this with, some other pill that I'm taking, et cetera, et cetera. Or grapefruit juice. I actually was reading or listening to a podcast the other day about the oxalates in grapefruit juice and how they can severely inhibit your detoxification capacity, your P450s, which insects have as well. And therefore, if you take a drug and drink grapefruit juice, well, all of a sudden you can't metabolize that drug enough, and it leads to an overdose. So, anyways, those things are tested for with drugs for humans. They could be tested for with pesticides for bees, but they are not. In addition, there are simple things or simple assays that have already been developed by the pesticide industry to look at these drug-drug interactions. One of them is actually referenced in this paper that we're looking at right now. So that was a pesticide interaction, a really slick bioassay. Actually, sorry, it's not even a bioassay, it's an in vitro assay. It's just in little plates, but they're like, 365 well plates or whatever it is. Yeah, here it is, Haas and Nouwen. So pesticide risk assessment at the molecular level using honeybee cytochrome P450 enzymes, a complementary approach. So that basically, I know it's a lot of jargon in the title, but basically what that paper does is it validates a method that the pesticide industry, so Ralph Nouwen, he works for Bayer in Germany, right? So this is a pesticide company, and then his grad student Julian Haas, they developed this protocol based on an FDA protocol for looking at drug-drug interactions to look at interactions between fungicides and insecticides. So these fungicides, these cytochrome P450 inhibitors, can potentially reduce the ability for bees to detoxify insecticides like neonics. And what he did with this assay is show, all right, we can rapidly screen a ton of fungicides against a ton of insecticides and see which fungicide-insecticide interactions might be problematic. So even the pesticide industry is contributing, these tools to be able to include them in risk assessment, and yet they're not included. So they should be.
So the capacity is there. You just need to have some incentive somehow. It is,
you got it.
fascinating to me. And that goes into many different levels. The other thing is find a way for those pesticides do not spread everywhere, right? Because then we don't have the interaction with, I don't want, people spraying things in my neighbor and end up in my backyard or in my coffee, that kind of thing. There are ways to avoid those spread, depending on the pesticides of conditions. There are ways that we can do to avoid those tools that farmers need to use to end up in other places they're not supposed to.
Yep. Yeah, no, you got it. I would say, yeah, again, so we're just talking about the registration process, what's making it legal to sell these pesticides or not. But obviously, once they're put out there in the world, well, now it's up to growers or other pesticide applicators to decide how to use them. There's label language, and there's certainly some recommendations on how to use them, but really you can do whatever you want once it's out there in the world.
And I'm working in the field on a daily basis with farmers and beekeepers, commercial guys, and the things I see, make me don't want to go back there. I feel that I'm going to be exposed or sick sometimes, depending on the job that I'm doing. So in that regard, I have stories to tell, but maybe I'm gonna keep that for another podcast, another day.
There are books written on that topic, and there are very
Uh,
cases of yes, human exposure to pesticides in agricultural environments that lead to diseases and death.
yeah,
Thankfully, pesticides have improved for human exposure and risks, from the use of them in agricultural contexts. There's certainly been improvement over the last 50 years. We have fewer people as a result of dioxin, and they've been banned at this point. But yes, it's no pesticide is risk-free, and certainly I have my own stories to tell. Thankfully, I don't think I have any medical issues, but I work in a lot of crop pollination settings, and I see a lot of things. And yeah, there's some problems for sure. We won't get into those. Those are more anecdotal than science-based, but
yes. Okay, so we define. I think we have that clear to everybody. For the people that do not work with this, that is easy to see that we have problems in the way we manage risk assessment and the way we regulate the approval of those chemicals. That's going to end up very likely very close to us. So
I would maybe just one last thing, and
okay,
yeah, maybe
maybe
we're getting too bogged down in this topic, but I just want to add one last thing. So the last thing that's included here, you can see on the left-hand side right here. So it's approved. Non-target effects are identified. On the left-hand side, sort of up towards the top. So it's approved. Non-targeted effects are identified, and then the pesticide is banned. That's a very difficult process, but as it occurred multiple times, it's currently occurring with neonicotinoid insecticides. So even though there is now literally decades of evidence that neonicotinoid insecticides are having extremely bad non-target effects on pollinators, and there are links between population decline of pollinators in the United States and neonicotinoid insecticide usage, it still is considered federal level any potential restrictions on those that particular class of pesticides. But states have stepped in, and this gets to the third article where New York just banned neonicotinoid insecticides for certain application contexts, and other states either in progress to potentially ban neonicotinoid insecticides in some application contexts or is being considered. So that is the unfortunate situation that is occurring right now, right? So on this left-hand side, an inadequate risk assessment process has played out. There's all sorts of drama that occurs after, oh, geez, the whole thing is happening. And then there's all this ecosystem of, well, what can we believe it, et cetera, et cetera. That eventually results in, some of the things that I'll touch on in the third article, which is, disinformation and lots of power and money dynamics at play. Yeah. But anyways, what results through all that drama is that, pesticide is banned. Wouldn't it be nice if the risk assessment process was so strong that we didn't have to deal with all that drama, that it was just fairly accurate in actually predicting, risk to bees, and therefore we could predict that there were not going to be these horrible non-target effects? Or what I wanted to highlight here, if part of the risk assessment process actually included post-registration monitoring. Post-registration monitoring occurs for every single drug that is released by the FDA. So the best example of this that most people can remember, since it just happened a little while ago, is the AstraZeneca vaccine during COVID. So I'm sure everyone remembers that, we had this thing called COVID, probably impacted most people's lives for a couple of years, maybe still impacting people's lives. I hope you don't have long COVID if you're listening to this. Anyways, the AstraZeneca vaccine was that vaccine that was released, and then all of a sudden, well, actually, we're going to hold off on it. We have to do a little bit of further work to see if it causes blood clots in humans and potentially, actually does more harm than good, in this vaccine. Why did that occur? It's because of post-registration monitoring. Okay. The AstraZeneca vaccine was registered. It went through the approval risk assessment, process. It was released, and then immediately after it was released, monitoring occurred of how the thing out into the real world. Is all of the estimates of risk true that we went through in the risk assessment process? Or are there things that we didn't actually capture in that risk assessment process? They were worried that they didn't capture something. So therefore, they were going through this post-registration monitoring. There is no post-registration monitoring in the United States, okay? The only people who are doing any sort of post-registration monitoring are folks like myself and other researchers who are spending their own time out of just their own interest in this topic and trying to get federal or state money or private money to go out and actually do these post-registration monitoring assessments. Because of the lack of data and the lack of number of people, I mean, it's literally like a handful of people in the United States who are going out and doing this post-registration monitoring. That means the data that we have for what is actually going on with pesticides in the real world is that big. That is a major problem for this is why the top pesticides and bees is so controversial, and why we say, is there enough data to actually say something or not? It's because there's so few people who are actually even looking into it that it takes decades for those data sets to finally accumulate, so then we can actually say something conclusive about this. We are finally at that point with neonicotinoid insecticides, right? And with the uncontroversial truth that neonicotinoid insecticides are harming pollinators and contributing to pollinator declines, there's still disinformation that goes on because of and financial interests of various companies and people, et cetera. And we can get into that as well. But really, that is a major problem, right? So just the quantity of people and the quantity of time that's and money that's invested in monitoring, that trivial fraction of time, money, and people means that it's just, we don't really know for a lot of different pesticides what the real impact is in the real world.
And this is a shame, because the real experiments happen with us and everybody else around, and then we need to rely on people's observations, those little stories that accumulate here and there, terrifying stories that we don't know what happened, people getting sick and nobody know what happened, and nobody investigate those things, and then become, oh no, it's just people weak, or I'm sure there are some of those cases that could be related, but we're never gonna know if we do not have systems in place to evaluate the truth, what's happening in real life in the population and in nature. All right, Scott, so maybe we should move on from the regulatory. I think we convinced people that we have some flaws here. There's much more to talk about, details on that. And if you're interested in that, please hit the subscribe button and join my email list, because I'm going to do a lot of content on that to explain this in very, very detailed, easy to understand, so everybody can even, teach to everybody out there and know what's going on in real life, so you can make your own decisions. All right, so let's move to the second one. So you talk about regulation here. What's the second one is about? Pesticides are currently harming bees across Europe. Why did you decide to write something like that, about that? Isn't that obvious? Maybe it's only for us.
Right. So yeah, again, every interaction that I have with politicians who are not, scientists, who are not into this field, every single one of those interactions starts with, I've heard a little bit about this, but my understanding is controversial. Right?
Yep. And then there is
And
a
I've
political
explained a little of the
calculation.
reason. Right. So I've explained a little bit of the reason why it's controversial. We just don't have a lot of data for a lot of pesticides in the real world and the impact they're having on bees. That's baked into the whole system of how this information is gathered agencies or not gathered by regulatory agencies in terms of post-registration monitoring. But we do actually have some scientists who work on this topic, and they've been working on this topic for over 5 decades. So over those 5 decades, we've accumulated a lot of data on a lot of different pesticides and what is really going on in the real world. There are multiple different types of data sets that contribute to strong inference about how pesticides are harming bees. Some risk assessments, have been done before. All right, what's exposure in the real world? What is the predicted impact of that exposure, and then combine those two data sets and say, all right, if the predicted impact is really bad at a certain level of exposure, and a certain level of exposure actually does occur in the real field, all right, we think that there's major risk to bees. So that's one way of looking at things. There's also longitudinal data sets that I get into a little bit with the next article, where it just shows that, yeah, there's declines occurring, and we know that usage of particular pesticides is stronger in particular areas over time compared to other areas, and those usage areas may be linked to those declines. So there's another piece of inference that says, all right, it's associational. It's not like proof positive that yes, that pesticides are causing those problems. It could be other problems, but it happens to be a longitudinal long-term data set which has many positive attributes and shows those links. And then there are experiments like the one that I'm highlighting right here in this article that actually put pollinators out in the real world. So this again was, I think, at like 108 sites or something like that. Yeah, 106 sites. There we go. 106 sites across 8 European countries. You can see all of the bumblebees that were put out there. So bumblebees turn out to be a pretty good bioassay organism for this. They're not as unwieldy as honeybee colonies to bring around. And also, we've talked a little bit about how honeybees are particularly resilient to pesticides to compare to other bee species. Why choose the most resilient species as your bioassay organism? Why not choose something middle of the road like bumblebees here, which is what these researchers did. And also they come in tiny boxes that you can bring to different places. So what these researchers did is they brought all of these out to these 106 sites. They measured population change of and growth of these colonies. So if you scroll down, I think there's a picture of the nest in there. Yeah, there we go. So there's a top view of the bumblebee nest. As you can see, it's not as beautiful as the hexacomb of honeybees right there, but that is the same exact thing that honeybees are doing. You can see some little pots where the nectar is. Those are the honey pots, and then those little blobs, the lightish blobs. Those are the developing either larvae or pupae that are in there. And then there's adult bees on the top of them. So it's just like honeybees. There's food, there's brood. Here in this picture, there's food and there's brood. But what the researchers did here, you can see them on the left. They measured the weight of the colony before putting them in for pollination. They measured the weight right sort of at the end of pollination to see how much they grew or shrank in population or in weight. And then they also counted every single bee in each of these colonies. So they looked at the total population within those colonies. In addition, bumblebees are very good at looking at fitness impacts of various stressors because it's a single event that occurs in the colony life cycle of bumblebees. So they grow, just like honeybees, they start small as a single queen and a colony early in the spring. They grow and grow and grow towards the end of the season. And then honeybees, they're, as everyone knows, they're reproducing in the spring, so they sort of anticipate that, you know, something might happen, so therefore they swarm. Bumblebees don't do that. There's no swarming in the spring. They grow and grow and grow through the season, and then at the end of the season, depending on how big the colony is, how many new queens are produced. Okay, so a bigger colony will produce more queens. A colony that has done better with stress and more resources will produce more queens. That's the reproduction into the next generation. So what they measured here was queen reproduction after apple pollination, because these colonies were put in at just the right time for them to grow a little and then produce the new queens for the next generation just after apple pollination. So they measured this sublethal response that we think is really important for population dynamics, reproduction. Okay, so what do they find? If you scroll down, they found this very strong negative relationship. Okay, so if you look at panel A there, the first one, this is just all the different colonies, or sorry, all the different countries where this was involved. This was a massive study across, I don't know how many different countries it was, 7 or 8 or something like that. Looks like
a lot of people.
And then all of these different sites at the different countries. Yeah, go ahead, Umberto, what were you gonna say?
A lot of people involved, I'm sure, to monitor all those places in different areas in different countries. Yeah,
you got it. Yeah, and then you know, there are some of the other different panels here, but really it's fine just to look at panel B. That really says the same thing as the other panels. And as you can see here, with more pesticide risk, okay, and I'll get to that in a second, there's less total production. So there's less, I think this was weight of 20, is that right? No, I think that's just total bees that were produced.
Total production, yeah. Total production. And then we have,
and the same thing for weight gain.
And
also, yeah, I guess it's weight gain there in the bottom as well. And then I don't think they actually talk about the queens in this figure, but the queens produced where it's the exact same relationship, where there's more pesticide risk, there's fewer queens produced. Okay.
And yeah, this is very important. Then we come back to what you're saying, that we don't see dead bees, but they're not reproducing as much, which is
exactly
responsible for the reduction anyways.
Yep, you got it. So, all right, so let's talk a little bit about what's on the pesticide risk. What the researchers did is they gathered the pollen that the bees brought back to the colony. So they opened up, after the experiment, you know, they took it out right at the end of pollination. They gathered all the pollen that was in there, that the bees had sort of accumulated during the pollination window. And they sent it to a lab that tested for all the different pesticides in there. Okay, so they did a multi-residue analysis, not to look at one particular pesticide, but just any pesticide that might be in there. That's a pretty expensive thing to do. I know that because we do that in my lab. We actually run an analytical facility in my lab as well, because it's difficult to do. So we're trying to make it a little bit more available to the public and reduce the cost. So anyways, they did that, spent a lot of money on those tests, and found that there are a lot of pesticides in every single pollen sample. Not a single pollen sample was uncontaminated with pesticides. That's not surprising to me because I see the same data from crop pollination. This happened to be mostly in apple that they did this. You can see there were 2 crops, so apple and then that OSR, the yellow thing on the left-hand panel there, that's oilseed rape. And again, we don't need to get into the differences between apple and oilseed rape. That's a complex story that's difficult to explain. But basically, yeah, there's a negative relationship across both of those crops combined, and it's driven largely by apple.
I will try to bring the authors to explain themselves, so don't worry about it.
Perfect. So, okay, so they tested all the pesticides, and then again, what's on the x-axis? That's a combination of 2 things. Number one, the types of pesticides that were in there in each sample, right? So let's say a given sample had 3 different pesticides in it. It's the combination of all of those three pesticides weighted by how toxic each of those pesticides are in individual tests to bees. Okay, so it certainly could be that there's interactions, that synergisms, antagonisms, whatever going on, but we don't have any data on that, so we can't use that. What we do have is these LD50 studies that are required during the pesticide registration process. And we know that things like neonic are extremely toxic to bees. So, a very tiny amount will result in 50% of those bees being killed, versus something like cyperdinyl, a fungicide, being relatively non-toxic to bees. Okay, so they've combined the toxicity of each of those three pesticides with the type of pesticide that's there to come up with this metric of risk on the x-axis. It's a really good way. There's certainly, it would be great if we could do even better ways, including interactions and all of that kind of stuff, but it's the best way we have available to predict what real risk is in from a cocktail of pesticides. What you can see here is, as you have that increased toxicity weighted concentration of pesticides, you have fewer bees produced, less weight gain, and fewer queens produced, which means that those pesticides that are approved for use, during commercial apple or seed rape pollination here, as you can see, are having a negative effect on those bees. This is a direct link now between what has occurred during the pesticide registration process, what is being used in the field, and a decline in performance of bees that has fitness implications, those fitness implications being reproduction, which we would predict have negative population dynamics for bumblebees in this particular system. We also know that bumblebees are declining throughout Europe, and they have been declining for several decades. This right here is evidence suggesting that pesticides are playing a role for that decline in Europe.
A gigantic study that is very hard to go against, I would say, to say otherwise. It is clear pesticides are hurting those bees silently, because you don't see death, but you don't see birth too in this case.
For sure. And I guess, again, just to zoom out a little bit, we're focusing a lot on pesticides that's the whole topic of what we're discussing, right?
Yeah.
It is not just pesticides that are causing problems for bees. This is the other thing that I try to convey. I actually just conveyed this 2 nights ago to the Vermont Senate when I was testifying on their, proposed legislation. It is not just pesticides that are causing problems for pollinators. If there was a silver bullet, if it was just neonics that were causing problems for pollinators, great, ban neonics, problem solved.
Done.
But it's not, right? It's multiple things. It's pretty difficult to discuss this topic with policymakers. So, for example, just in that testimony that I gave to the Vermont legislature a couple nights ago, I got a question of, hey, I've heard Varroa is the major problem. If we just fix the Varroa problem, can't we just solve the problem for pollinators? Yeah, we can certainly make headway on that topic, right? If all beekeepers adequately controlled Varroa, I think that we would greatly reduce honeybee colony losses throughout the world. Now, that said, it's not the only stress, and we certainly know that pesticides, for example, neonics, there's really good evidence that they actually contribute to increased susceptibility to Varroa. So
in all the viruses that.
Yep.
Yeah, you please go ahead. Sorry.
Oh yeah, no, again, yeah, because you've done some of this research, I know.
Yep.
Umberto.
I did.
But yeah, there's interactions that occur, and there's a lot of involved. Sure, we could improve the situation with Varroa, but we can't fix it. The same is true for these restrictions on pesticides. We're not going to fix the problem with pollinators if we just improve the situation with pesticides. But we're certainly going to improve the situation with pollinators, as you can see from study here.
Scott, I have a theory, hypothesis actually in my head. I want to share with you, because once I got your report and read and combine that with my personal experience, almost 17 years now with honeybee research, and everything that I see in academia and also in real life in the field with farmers and commercial beekeepers, I start to put things together, and this cannot get out of my mind. Like yes, we know Varroa is a big problem. It's a gigantic problem. But I also know from many years that bees are very flexible to get rid of problems. And I wonder if the bees are losing their capacity of because there are too much going on. And that's going to be one of the contributors why Varroa has become so much a big of a problem, because bees cannot is reaching a point that they cannot deal with that. I know they get rid of many bacteria. You just breed. Before, you talk with beekeepers from the past, we just breed. Just let them breed that out. They're gonna figure that out. And that's happened many times throughout my career. And when I talk with older folks, they said the same. We didn't care. We just let the bees do their job. And the only thing that I go back to the literature and I see there was an increase is the number and the volume. It could be a correlation there of the pesticides and the capability of bees to, to breed and to get rid of diseases. I'm not sure, but I would love to find ways to test that.
Yeah. I mean, we know that there's genetic variation for, basically everything. There's evidence that there's genetic variation for resistance and susceptibility to Varroa. We know that there's genetic variation in honeybees, I should say.
Yes, yes.
For resistance and susceptibility to Varroa, to viruses, to resistance and tolerance to viruses. And we also know that there's genetic variation to for resistance and tolerance to pesticides. So some of the more interesting work in the larval assay realm has actually shown that, hey, we can't just use one genetic line, to do these larval tests, because they vary greatly between genetic
Yes,
lines that you actually put in the lab. So the
that's true.
variation is out there that selection certainly could act upon. But I think, yeah, your question is, hey, is there just so many different stressors going on right now that it's hard for selection to actually occur, and result
It,
in a resistant bee, because yeah, they're just being hit too many angles, and it's just hard for them to really center on anything. I
what
think
I
it's a great
base
question.
myself is like, and I'm again to the people at home. We are scientists, but I am speculating here right now, just putting my thoughts out there. But it's really hard for me to understand. We cannot breed for everything, right? And now everything is hitting the bees, and all of those things are together. If something happened, Varroa goes up. If something happened, these viruses go up. So we can't breed for everything. And it is a concern of mine from the perspective of commercial beekeepers that I need to find solutions for them to maximize, the operations. And sometimes I feel like I don't know what to tell them. But we need to keep trying.
Yeah, I think that's the again, thinking a little bit more generally about this topic, I think you're absolutely right. Right, there's a lot of different stressors that are on bees right now. There certainly are different breeding programs. Most of them focus right now,
True.
but there are breeding programs for other types of things. But really, what makes it way more difficult with bees compared to plants or other domestic livestock like cows. So, just for example, my partner, she works on dairy cows, and she's always amazed when she says there's breeding efforts in honeybees, but how do you? There's no controlled breeding, right? Like, sure, you
Yeah.
can,
Yep.
potentially do some artificial insemination, but unless you do that every single, generation, which is basically impossible in any
Yep.
beekeeping operation, there's just open mating. And who are they open mating with? Well, probably bees within your own operation. They could be feral bees that are around where you live. It could be other people's bees, et cetera. So it quickly gets diluted,
Yep.
compared to dairy cows, for example, where it's closed. every single generation that goes on in breeding, it's known exactly what the genetic identity of the sire is, and also the female. The same is true for plants, right? So crop breeding, we know exactly what we're selecting for, and we're selecting for particular things. So on the one hand, it's great, that you have all this control in other organisms. And on the other hand, you might be missing the boat that nature could tell you a little bit more about. That's just something that we need to deal with, that messiness in breeding for honeybees, which could be a positive. You're right? So let nature figure out the sort of differences. But at the same time, it's a little hard to let nature figure it out when it's a domesticated species. And we're doing all sorts of things through it that, we're transporting them around, we're imposing all sorts of different stresses that whatever those genes that are being introduced, on, might have absolutely no idea how to handle those particular stresses. So yeah, it's a complex topic with, we're scientists, and certainly we can speculate on it, but we have no answers.
No.
I think, I guess, how I started this was I was trying to say, just zooming out on this, I think that's another thing that has been really good, and I've found very useful to convey to policymakers, is science can get you so far, but it's not like science knows everything. Science and scientists don't know everything. I certainly don't know everything. I know a small fraction. Actually, the more I know about science, the more I realize how little I actually know.
Yep.
And sure, we can speculate, but a lot of this stuff is it's unknown. And we can work. We just have to, work as hard as we can and try to be as logical as we can be about trying to solve different problems. In the end of the day, I have one lifetime, to do it.
Yep.
And other scientists are the same way.
Since you mentioned that you're being invited to educate policymakers, so I think that comes to what happens with this article right here. So tell me a little bit about this article, your experience with legislators, and some of the problems that you faced that you were not expecting.
Yeah, sure. So this has been, I would say, in my professional career so far, this has been the most educational thing that I have participated in. So up until 2018, I think it was, that we were commissioned to write this report, I was just your, ordinary, sort of dry scientist who never talked about the social implications of science, just did science and hey, tried to have some sort of positive impact on the world, or at least on science. We were asked by Governor Cuomo, our former governor in New York, to write a report on the risks and benefits associated with neonicotinoid insecticide usage in New York State. I believe the impetus, I'm reading into this, I never actually spoke with Governor Cuomo personally. I just spoke with all of his people who interacted with us, his administration. But I believe what the impetus was is he wanted to make a statement on an environmental issue, and everyone has known that neonics and bees have been in the news for 2 decades or something like that. So he wanted us to really drill down on what is and isn't known about neonics, both from the pollinator side of things, but also from the economic benefits side of things. Why is that important? Well, any policymaker who is going to potentially do something on an environmental issue wants to know, well, what's going to be the impact on humans, right? So we need to know, if we're going to do something about neonics that could potentially help pollinators, what impact is that going to have on growers who need to make a living and we need to produce food? Okay, so we took on this report. I took on this report before having tenure, which is in its own interesting story.
That's
I won't get into that
story.
here. I won't get into that here, but I will get into that in the book, so you guys can read that in the book when it eventually comes out. And there's, again, this is like more detail than anyone would ever need to know about academia, but there's a reason for tenure. And this is the reason. It's the ability to be able to speak on controversial topics, hopefully backed up by evidence if you're a good scientist. But yeah, prior to having tenure, sometimes there can be intimidation from scientists who do have tenure. Sometimes even within your own department.
Wow.
So anyways, yeah, I won't talk about that here. But what I will say is that I took this on because I was like truly fascinated about this topic myself. Know where the science landed on this topic. I had sort of a crude understanding that, yeah, pesticides were definitely having a problem. We had published some, or pesticides were definitely a problem. We had published some on this, but I didn't really know the full neonic literature on neonics and bees. So I thought that would be interesting to really get to know that literature inside and out. And then I didn't know anything about the economic benefits literature. I didn't really know, well, what is the evidence that neonics really are having a benefit in all of the different application contexts in which they're used. So I was fortunate to be able to have money from New York State to hire an agricultural and economist to take on the economic benefits side of things and to lead the report. I took lead on the pollinator risk section with some help from a couple people in my lab. So what we did is we worked on the report for 2.5 years. We poured our heart and souls into it, just because we wanted to not do something superficial. We wanted to really write the report on this topic. I wanted to know what was the answer, from a scientific perspective. When you really weigh risks and benefits, where is there evidence and where isn't there evidence? In hindsight now, I mean, I just kind of figured that would be good to do. There's been a lot of sort of superficial reports that have been written on this topic, including stuff in the EU that even went into the decision for them to outright ban pesticides or neonicotinoid insecticides. But I wanted to do something really comprehensive for my own, well-being, just to know that what I'm saying really is based in fact and like the state of the art of the knowledge. But also I kind of had to do it because I was pre-tenure. I couldn't get by with something that was, sort of half-assed. So we did it. We wrote a 432-page report. It took us 2.5 years. We published the report, and it was immediately attacked. I also knew that would probably be coming. I didn't really fully realize the extent to which it was attacked. And I realize now in hindsight, the reason it was so attacked is because every statement that we have in there is backed by very solid evidence, and it represents a very big threat to the pesticide industry, who wants to make money on neonicotinoid insecticides. Okay, so therein lies, sort of the background of what happened. Fast forward now, and we can get into details of all this sort of what happened during the fast forward period. But fast forward, what happened? New York State, after a couple years now, has decided to ban neonicotinoid insecticide seed treatments from field crops. That includes corn and soybean. And we can talk about why we focused on that as the key result from the report, and also why it's the key result from the legislation. And then they also went, I think, maybe beyond what the science says, but more just sort of in terms of making a political statement. They also banned neonics from golf courses and ornamental plants, which I think is good. I think it does absolutely reduce risk to pollinators. But from a landscape scale perspective, I would say there's other types of application contexts that could have reduced risk to pollinators even more if there had been further bans on neonicotinoid insecticides. But those were chosen. I think it's also a little wishy-washy to say what are the real economic benefits of using, neonics, especially in golf course settings. I mean, I guess, yeah, you can improve the aesthetics, but where do you put a dollar value on that? It's pretty hard to put a dollar value on that in terms of economic benefits. And certainly, yeah, maybe the aesthetics are increased, but do you really think that the aesthetics are the best thing. There's other insecticides that can be used on golf courses that are just as efficacious as neonicotinoid insecticides that pose less risk to bees. And also, boy, wouldn't it be great if you had a golf course that says, hey, we're a sustainable golf course. We like pollinators. We don't nuke them all with neonics.
Yeah, and we invite the good golfers that need a little bit more challenge.
Yeah,
perhaps.
But so anyways, that's the legislation. It was passed in December of 2024. So it's been, what, 4 months-ish now since it was passed. The one interesting thing, and this can get into like what happened in that fast forward section of all of the fight over this, legislation and what our report was about, et cetera, et cetera. It was delayed by 5 years in the last minute, in large part due to pressure from a grower advocacy group. So even though there is clear and present danger from neonics right now in field crop settings, even though there is almost no evidence of economic benefits to farmers, there's very, very minimal, like infrequent benefits to farmers in field crop settings of using neonicotinoid insecticides on seed treatments in those field crop settings. Even though that's also true right now, apparently we have to wait for years for some reason for neonics to finally be phased out in that particular setting. And we can get into the reason for that if you'd like.
Oh, I'm aware. I interviewed the lawyer behind and the group behind the legislations. But if you didn't see, if you guys at home want to know more about that, I cover in great detail. Is in my podcast in one of my videos, and I'm gonna put in the link in the description of this video if you want to go further in that kind of details. But that being said, so we have that in New York now. Is going to be phased out. Neonicotinoids need to go away, or it's going to diminish almost 90%, I believe, or a little bit more than that, the use of neonicotinoids in the state of New York. But apparently this is also spreading. There are other states too going to the same direction. And you just mentioned that you were invited to testify in Vermont to educate the legislators there. Can you give us a little overview about what's going on in Vermont?
Yep, sure. So basically the exact same process that had played out in New York during that fast forward period of about 2 years, 4 years, actually. It was almost 4 years, but that it took place. There were multiple iterations of the bill, multiple testimonies, multiple meetings with lots and lots of different people. Anyways, that same process has now played out in Vermont, and a similar bill that has focused largely again on this application context where there is clear and present danger to pollinators. That's field crops, corn and soybean, the seed treatments that are used on corn and soybean, and then very limited evidence of economic benefits for farmers, and also, I should say, viable replacements for neonics that don't pose as much harm to pollinators, or at least bee pollinators. So the focus of the Vermont bill is the same on restricting those. I believe the current iteration of the bill is mimicking New York. So whatever happened with that 5-year delay in New York is now being mimicked by Vermont as well. So they're proposing to delay for 5 years before this is implemented. My personal opinion on that is it's not needed for multiple reasons, and we can get into that. But that was a successful lobby attempt by the pesticide industry to delay, which they have been. Again, there are literally books written on this, and I can tell you the titles of these books where they show conclusively with evidence that this is a tactic of the pesticide industry, is to delay defect. So anyways, I believe the pesticide industry was effective in delaying. This means more money for the pesticide industry because they're able to sell neonicotinoid seed treatments for longer. And then, yeah, so they'll be there for at least 5 more years in New York. We'll see what happens with the legislation in Vermont. If it does mimic New York, it will be the same thing. And then my understanding is other states are considering legislation as well. I've been talking to a few legislators about various things that they're considering in other states.
Okay, I think that's good news to more people are at least looking at it at least. But it was something that got across my mind is, when I look around and I said, I when I was trying to educate myself, I said, oh, let's see what's going on YouTube and things like that. Then very soon I realized that I'm the only person on YouTube talking about pesticide. And then I start to realize how just a handful of people that talks about these things that I know of is you, Dr. Judy Smart in Washington, and that's it. And you just mentioned that talk about the risk of pesticides, the synergistic effect. I see some talks of, oh my God, you just mentioned his name.
Reed Johnson.
Reed Johnson. Yeah, Reed. Yeah. Sorry, yep. Reed. Reed is a good friend. So, and I want to ask you.
We have been going for almost 2 hours with this interview.
I know.
I give you a pass. So
okay, thank you.
Where you are too. So.
No, I'm good. I'm good with that because it's good content. And I appreciate your time. But my question to you is why there is so few researchers or people talking about this? Do you think it's fear? Tell me a bit about your experience with the legislators and the attacks that you got. Is there any argument that we should be looking at, that we should pay attention on that? Can you give me a little overview about why and your experience with that?
Yeah, I guess what I can tell you, again, this is anecdotal. There's no study that has actually been published on this, but I could tell you from a study that could easily be published on this. Whenever I talk to people about the topic of pesticides and bees, whenever I talk to researchers about this who really are in this field or potentially thinking about getting into this, they always roll their eyes when we talk about public engagement, and they roll their eyes in fear. Okay, so I want to be really clear about that. It is fear that drives people away from this topic. Why? Because they have money and power. All right, that's what it is about. I can tell you from personal experience that there is intimidation directly from the pesticide industry, and there is intimidation indirectly from the pesticide industry when you start to wade into policies that potentially cut into their bottom line. Okay. This article right here highlights two of the more egregious examples of direct quotes from either a direct or an actual industry representative from Bayer, trying to spread disinformation about our report. And you can read all of this. It's all in writing. It's all referenceable. I'm giving you the links in this article to where these words were actually said that you can view on your own computer. You can view his words and how they are a lie. And also indirectly through people who, at least historically, have had close ties with the pesticide industry, and the pesticide industry has even drafted articles. This is again referenceable in this article right here. How Monsanto had actually drafted an article for this person to publish under his own name. Whether that's true or not for this particular article, he wrote a series of lies about our particular scientific report. I don't know. But what I can share is that he spread disinformation about our science in an attempt to discredit it. I don't get into the intimidation that has occurred from the pesticide industry in this particular article, but I will be getting into that in the book, and that's some pretty insidious stuff right there. So, why is it that researchers are avoiding this topic? Fear. And is that fear based in reality? Yep, unfortunately.
Wow, that's a statement. And from my experience inside academia, and I have a little problem in academia, so please forgive me if I go too hard on academia because I try 3 times and I always have problems with. And I'm very late, I'm a very easy guy, and I speak my mind. I always do, and I always have problems on that direction. And I thought that would be the space that we have the conversations. I really want people to change my mind. I like to be wrong. I like to be, my mind blowing. That's a life-changing experience when, oh my God, why I was thinking that. Now I have all these facts and information, and now I can go to a better direction. And I start to have problems in academia to have more tough conversations, and then I start to pay attention on things, and I have photos, and I can't publish those photos. I think I need to consult a lawyer, I guess. The letters in all mailbox of the 3 universities that I passed through. You need to go to your mailbox where you see the mailbox of all the researchers there in the department, the office. And there was those letters addressed personally from Bayer, Syngenta, in every single box. In every place I go, there is all this Syngenta and Bayer and all these people. And we try to talk about things, and where they are there, that are, I can clearly see there are systems in place. And I'm always stunned, like how the researchers accept or don't realize there is this possibility too. Sometimes researchers are too into their work and their environment and fighting for grant money, and they're not paying attention on the system, how the system are playing sometimes them. That's my 2 cents here. And it was very hard for me to need to leave academia. And actually, I'm better now, to be honest. Dealing directly with beekeepers, trying to educate the people through what I can do with my channel or in personal and in talks and beekeeping conferences. So I'm happier. But it
Good.
is sad. It is sad to say that I have great friends. I like academia to be a free environment for the scientific method and thinking process. But I have to say it is not. I'm sorry, unfortunately. And I think this is a clear case that you just mentioned. People are scared. And when you're
Yeah.
scared, you don't want to lose your job. A lot of those companies finance a lot of the grants that you people gonna get, behind the scenes, and have a lot of influence on who hires who or who fires who. That's true. That's a fact.
Yeah, no, I mean, there's a lot in this topic, and I should qualify everything I say that I'm not a sociologist, right?
Yeah.
I'm a hard scientist who's learned a lot about sociology, and this is why I say that in my professional career, I've learned the most over the past, 4.5 years, 6 years, I guess, whatever, since we started writing this report. I learned a lot about the sociology and the economics of this particular topic. And I've learned a lot about how science, I guess, the place of science and the place of academics like myself in the real world on topics that people care about. I would say I didn't know that before. I certainly I studied topics that I cared about, but I wouldn't say that a lot of other people cared about it. Maybe a handful of scientists that were working on the same topic as me. Scientists operate within that realm. They really push the boundary on some niche topic, and they really care about the people who are closely working on things that are related to what they're doing. So again, it's like a handful of people that you really have close relationships with as a scientist who's really working on some particular thing. Once you step out of that and start working on a topic that the public is interested in and that they all have very strong feelings about, both pro and con, whatever the science says, it starts to become a very big learning experience. And I would say, yeah, I've definitely been learning on the fly over the past several years. I have learned some things, from my clients, and then also reaching out to folks with better expertise on this particular topic. So sociologists, economists, and various people working in sort of the science policy industry interface. I've learned a lot from reading their materials and also giving or talking with them. So I'm hopeful that you can tell the way that I'm presenting myself right now and how I'm attacking this particular subject. I'm hopeful that with more transparency, which I feel is my role as a scientist, and actually I don't just feel that, I know that's my role, right? As a university scientist, that is the role of a tenured university scientist, is to be transparent about what the data actually do and don't show, and to communicate that data. Because if I don't do it, no one else is going to do it, right? So that is the role of university scientists. I've taken on that role. Actually, I'd say I've accepted that role because, similar to what you were saying, there's a bit of trauma involved when there's this crazy stuff going on where you're like, oh my God, what is this person doing, right now, and why would they say and try and undermine my entire career? There is definitely trauma, and there's lost, there's sleepless nights, etc. I certainly had plenty of sleepless nights over the past several years as I was directly or indirectly being attacked by the pesticide industry, and the dean was being copied, to emails, etc. So there's trauma in that, but I would say I've accepted my position on this topic for two reasons. Number one, through the process of writing this report and doing research on this, I've come to realize that I'm actually one of the more knowledgeable people on the planet for this topic right now. And I don't say that to be egotistical. It's just like,
Sure.
hey, I actually know what I'm talking about on this topic. So let's get that word out there. And the other reason is, because I've become knowledgeable on this topic, I've realized where some of the shortcomings are. And I've realized that, listen, I'm not just a hippie environmentalist. I certainly have environmentalist leanings, right? There's a reason why I focus on bees, but I love agriculture. I love food. I realize that pesticides are needed in modern agriculture, or at least our current version of modern agriculture. It would be stupid of us to ban every single pesticide that's out there. But it might not be stupid for us to ban particular pesticides that maybe have been approved through a faulty registration process or an inadequate registration process that are really causing some pretty big harm for wildlife, so these wild bees, and also agriculture itself. Honeybees are agriculture, right? So we have to figure out a sustainable ecosystem in which all of these different facets of agriculture and wildlife are going to be able to coexist. Otherwise, number one, it's economic harm, in the short term for both, beekeepers and potentially growers. But also in the long term, it's just not sustainable. We can't continue what we're doing on this planet. And in the way that what we're talking about here, the specific example of pesticides, we cannot continue using pesticides in the way we're doing, and just expect that the problems with pollinator declines are going to, evaporate, right? We have to change what we're doing, but the question is how to do that in a sustainable manner that does not cause harm or adverse harm to beekeepers and to growers and to industry. I will even put industry in there, say that industry is not, private industry is a wonderful thing in this world. There are some people in private industry that I would take exception with, how they're interacting on this particular topic. But if industry would just be responsible, if the pesticide industry would just make some responsible decisions and stop putting this ridiculous disinformation out, attack scientists who are actually telling the evidence, we will be in a way better situation. All right. So let's all calm down. on this topic and actually have a real discussion, about how do we create a sustainable system, both from the government perspective, from pesticide registration at the EPA, for post-registration risk assessments, monitoring, et cetera, but also from industry. They're 100% milk every single last dollar out of a side, but also considers potentially some of the environmental harm that might be occurring.
Yeah, you said it all. I just want to add a little bit regarding I am in pro the industry, but I'm very a big fan of the human brain. We can do better, We have a brain, we have a system and people. When we identify a problem, hiding a problem is not a solution. We
You
just
got it.
we can fix it, we can make another chemical there to replace that one that is better, or we can create solutions. What we cannot is just put under the rug and pretend just because somebody's making some money. That's dumb. That's not supposed to be human being kind of brain, homo sapiens. This is homo dumbiest.
I like that. I like that.
Something like that, that's what I want to wrap this podcast, because we already spent 2 hours. I want to thank you, Scott, for your time, and say thank you for your courage, your great work, and educating not only us, the academia, but the whole world. So do you have any other message before I wrap this up?
No, I think we've covered enough in over 2 hours of chatting. But yeah, no, thank you so much, Alberto. I was a little worried at what was going to happen during this interview, because it is a controversial topic, and great, we're just going to put this out on the internet, right?
Yeah.
But I think this discussion has been really good. Hopefully listeners will realize that, hey, let's just all be adults, right? Let's all be adults in the room. Let's have a real evidence-based discussion of this topic. Let's stop it with the, he said this, they said that, et cetera, et cetera. Let's just and make evidence-based decisions to improve the sustainability of agriculture. We will help ourselves in the long term if we do that.
Yep, you said it all, my friend. Again, thank you. And for you guys at home, all the links is going to be in the description of the video, so you're going to have access to everything that we talked here. I want to thank you at home for your time, and I see you guys in the next video. Inside the Hive TV, the show about bees. See you guys next week.